All right, so we're going to be looking at the three different forms for our quadratic equations over the course of the next couple of problems. We're going to do kind of bounce around. So this first one is giving us an equation. They say, suppose that this expression is giving the height of a diver. Oh, sorry, that's not supposed to be that. There we go. Giving the height of a diver above the water in some meters. T seconds after their thing. So it's time and their height. How high above the water is the springboard? Yeah. How do we know it's going to be 3? It's our y-intercept. It's our starting place. So it's 3 meters. Our C value is our y-intercept. When does the diver hit the water? So we're looking at part B here. How could we figure that out? Let's see, we've got our x-intercepts. Here's our wee sploosh. So how, not saying do it, saying how would we do it? How could we find x-intercepts? What was that? Graphing it. How would we do? Oh, what was that? What was it? Factor it. We need factor form to find roots. This one doesn't factor because they're jerks, but we would switch it to factor form. If we don't have a graphing calculator, which we don't because those suckers are expensive, and they've been expensive for 20 years. It's dumb. Okay. So, yeah, they give you a whole lot of spaces on here and not a whole lot of stuff. So then we're going to look at part C and think about it slightly differently. At what time, so if we think about my little sketchy sketch over here, we had our 3-meter springboard. There's our dude. And this is our water. How could we figure out at what time the diver is again at the same height as the springboard? Not saying figure it out, saying how could we figure it out? How could we figure out when they were at the same height as the springboard? What was it? What's the height of the springboard? 3. So over here, what's the height? 3.
Oh.
So if we want to know the next time they're at the same height of the springboard, what we're going to do is we would set our height to 3. So we could do this as 3 equals r minus 5t squared plus 10. That's not a 10, that's a 0. Plus 3. We're not going to solve it, but we could. We could solve it like that. When did they reach the peak of their dive? Or where do they reach the peak of their dive? What does that mean? Mm-hmm. More words. This. Helpful, but only for you and the people directly behind you. The vertex. That's the peak of the dive. How can I find that out? If we could have it in vertex form. So we would love to have the vertex there. What if I don't have the vertex? What if I told you that they're at the springboard at time 0, because that's when they jump, and they're here at 2. They hit that 3 meters at 2. How do you know that? I'm not saying you're wrong. I'm just saying how. Because it's right in between them. So with our factors, if we have a at the same height thing here, halfway between is going to be our vertex. Halfway, that's not how we spell half. There we go. Halfway between, that's too many E's. I'm really trash at spelling right now. Oh my gosh, that was trash. Between 2 roots or 2 solutions. So if we have factored form, we can find our vertex by making it halfway in between. If we have 2 solutions at the same height, like here we have our 3 meters guys. Halfway between them will be our vertex. So halfway between those factors, we can find the vertex. It's always going to be in between because parabolas are symmetrical. So, yeah, they ask a whole lot of questions about that, and those are the kind of important parts on this one here. We are not going to look at question number 2 because I do not give a hoot about velocity. If you care about velocity, go do physics. So we're going to look at number 3 because I want us to practice finding all the pieces in the forms again. So it's the next page, number 3. We've got a company's profit in thousands of dollars. Depends on the price of the item. They sent all their data out to 3 different accountants and said, please write me an equation for my profit. Their 3 different accountants came back with these 3 equations. What's that? Standard factored and vertex form. So those 3 accountants focused on different pieces, but it's using the same data. So what could we do to convince someone that all of these were the same? Like, how could we fact check our accountants? Yeah. You could graph them all. We could test some points. Like, if we pick 3 or 4 points and test them and they all match up, they're clearly the same parabola. We could multiply them out. So if you wanted to just convince someone that these are the same, we could show that. We can multiply it out. We could take this guy and we could do, when I say multiply it out, we could box it. Our P minus 3 and our P minus 9. We could do that. We've done that before. That's an algebra thing. We could multiply this one out with our same thing. We could box this one. P minus 6, P minus 6. Multiply it all by 2, add 18. Like, we can do this. And we're going to practice this later on today. Oh, snap. But there's reasons that the accountants gave us these different forms. Which one of these forms would be helpful for the break-even prices? When so what does that mean? Excellent question. So if we have a profit equation here, if we're breaking even, what is our profit gonna be?
When it's above the line.
Yeah, so when it's broken, when it would break even, what is that? So hang on, I'm gonna get this sketch. Because we're not losing money, so our profit's not negative. We're not making money, so our profit's not positive. It'll be right at 0. So our x-intercepts. So if we think about this, and I'm gonna give us just a little thing. Boop. Because we have a frowny face parabola because our a values are negative. So which equation shows us our break-even prices when our profit is 0? It's our factored form, right? What are those prices? Where does it break even? Where is our total 0? X-intercepts, specifically for here. Numbers. 3 and 9. Because if you think about our factored forms, it's always x minus our roots. X minus the roots. And a is out front. So our roots, or our solutions, zeros, x-intercepts, are going to be at positive 3, 0, and positive 9, 0. What is our profit when price is 0? I'm gonna draw it on the board just so we can talk about this. I'm gonna just draw this little sketchy sketch guy up there on the board. We already said we have our intercepts. We had 3 and we had 9. What is our x variable? Like, what did I put on my my x-axis over here? Is that profit or is that price? Price. What's on my on my y-axis? Profit. That's a T. Because we looked at here, our break-even prices happened when our profit was 0. So what is our profit going to be when our price is 0? Is it hitting here? No. Where could we find our profit when the price is 0? That is an excellent question. Where are we looking for it? Where are we looking for our profit when the price is 0?
All I know is it's going to be negative.
How do you know it's going to be negative?
Because the line on the left side is going to go down by the time it lines up with 0.
By the time it lines up with what?
0.
By the time it lines up with the what?
Profit.
I'm not saying you're wrong.
Oh, the 0.
The 0. The 0 what? Profit zero is here. Profit zero is here.
Yeah.
What zero is this?
Is it the y-intercept?
Is the y-intercept.
Oh, wait.
Oh.
Yeah, it's when my price is zero.
Oh. Okay,
Okay. So what is my profit, numerical, when my price is zero? What was it? Where are you getting -9 from? Because you're making up stuff and not looking at the paper? Look at the equations.
Negative 54.
-54. How do we know it's -54?
What's the first one?
Okay, because
C.
It's our C value.
yes.
It's our standard form. It's our C value. It's that y-intercept. I'm gonna put that on my up here. So we know this guy is our -54 y-intercept. All right, let's look at part C. What price will yield the maximum profit? Or go with, where the heck are we gonna find it? Hang on, guys. Where are we gonna find our maximum profit? At our vertex. So this is gonna be our maximum profit. So what is this point gonna be? Give me the ordered pair. How would we get that?
6, 18.
How do we know that?
Because the vertex form of the equation is
Because vertex form, that's our y equals a x minus h squared plus k. Our vertex form is hk. We also can spot here our vertex is halfway between our 3 and 9. So we know it's right at that 6. So it's a great way to kind of double check it. So what is the price that's going to lead us to the maximum profit? Which one's the price? 6. And it's going to give us a profit of 18. Okay, so sometimes even if we're looking at equations, it helps to give us a sketch to put the words in. Like my graph's not perfect. My 3 and my 9 are really far apart, and my 54 is really far down. Same thing with my 18, seems to be about as far away as my 54. Like, it's not to scale. There is no scaling going on here. And I didn't even plot any points properly. I drew a U and just labeled things. So sometimes it helps to just give yourself a little sketchy sketch of what we're going to do. But what we're mostly looking at here is finding those pieces. So we had our y-intercept. I'm going to come back here and change on part B. I'm going to write this as an ordered pair because we did the others as ordered pairs. So on our y-intercept, our x value is 0 and our y value is -54. Just because we wrote everything else, I wrote my vertex up on the board in ordered pair form, just so that things match. I'm just going back and making it match. Okay? Because what we're going to do for the rest of today is we're going to look at the next page. And there is a very large table. Nope. Down at the bottom. Number 5. I want you to start looking through that a little bit. That's really what we're going to focus on Wednesday, is we're going to be starting to switch those around. Tomorrow's e-learning assignment is actually question 4. So 86, this page is going to take us 2 days. Okay, so the question 4 is your e-learning assignment. It is going to be, like, it's a Canvas thing, so you're going to have to type things in there. But it's those same questions. Question 4 on the coyote problem. Page, 84. Page, this dude. Should have table thingy down here.
Oh, yeah.
Page 84. Question 4. Sorry. So this is our e-learning assignment for tomorrow. It's the same kind of thing. You're given the equations. We're figuring out where we started, our maximum height, figuring out when he hits the ground. It's the coyote with the Roadrunner from Looney Tunes. So that's the vibe. And then on Wednesday, we're really going to focus in on this table. So if we're getting started on it, we can. But we're going to focus in on finding all those pieces, finding our roots, finding our x-intercepts, finding our vertex. Okay, and we're going to practice with that on Wednesday. Tomorrow, technically, we have a Zoom call. I have to take your attendance.
For attendance?
Then you're going to work on homework 4.
Alright.
Okay? It's the Canvas assignment. It is the homework. It is would normally have been like the homework after today. And then we do the homework. So it's just like stretching it a little bit. So it's not like an additional thing. It would normally be the homework we do right here. Okay, so tomorrow I don't particularly care when you come into the Zoom room. I will mark your attendance when you come in. As soon as they say hi, you can leave. All of my classes are reviewing, so whenever it fits your schedule, come say hi. So I can mark your attendance. Other than that, I don't care.
So we'll have a Zoom schedule?
We have a Zoom schedule. I'm not teaching you anything. I'm not doing Zoom lessons. It just doesn't make any sense because 3/4 of the time we're either not paying attention or only like 6 people show up. Just saying. So it's not that big a deal. We are not pressed for time in here. We're good. We're good. So we're going to start working with these equations and really playing around with them. So I encourage you to look at number 4 while this one's still fresh, because it's really similar vibes. Where's our maximum? Where's our y-intercept? Looking at these equations. Okay? So you can get in and do homework. It's homework 3, I believe is what it's called. Whenever you wish, but that is what the assignment is for tomorrow. Okay, we have 15 minutes. So if you want to do that, and then all you have to do is come say hi to me, and then you're done for the day. 12. Great show. What's up?
I have a question.
I have an answer on that.